In this video, we will learn about the energy and the types of energy. The capacity to do work is called energy. Mr. Atul Malhotra from Puran Chandra Vidya Niketan, Kanpur will tell us more about this topic.
Energy. We can define the energy as capacity to do work. Capacity to do work is called energy. Now we study about the two types of energy. One, kinetic energy. You can write it as Ke. The another one is the potential energy. You will write it as Pe. Now we discuss the first one, that is kinetic energy. We can define it as the energy possessed by the body by virtue of its motion. By the virtue of its motion is called kinetic energy. We can write it as mathematically given as kinetic energy is equal to half mv square. It has the same unit of as work, that is unit is joule, and the dimensional formula is m L square T minus 2. Now we derive the relation for the kinetic energy. Kinetic energy is equal to half mv square. For the proving of this formula, suppose a block of mass m is kept on a surface and a force F is applied on it. We can prove this formula by taking the two different cases. One, by using when we say the force is constant, and the two, when the force is variable. First we will solve it with when we considered it, the force acting on a body is constant. Now let the initial velocity of body is 0 and the displacement produced in the body is d. So we can write it as work done. Work done is equal to Fd cos theta. Let the value of theta is 0 degree. W is equal to Fd. F is equal to, as we know in the last chapter, that is ma into d. Now put the value of A by the third equation of motion, v square minus u square upon 2d into d. Subtract these two terms, we can write m v square minus 0 ka square upon 2. This will gives you the kinetic energy is equal to half mv square. Now we discuss the another case for to find the kinetic energy for the variable force. Again, we have considered there is a block of mass m is kept on a surface, of variable force F is applied on it. Then we can write it as, for small displacement, work done is given as F dot dx. For complete work done, dw is equal to, we can write integration on both the sides. Then place the value of F, that is ma into dx. We can write it as dv upon dt acceleration and dx. Now we can write it as, that is dx upon dt into dv. Distance upon displacement upon time, we can write it as m, that is v dv. Now integrate the v from 0 to v. Now we can get w is equal to half m v square minus 0 square, or we can write w is equal to half mv square. Whatsoever with the amount of work is done, it is called the kinetic energy. That is, kinetic energy is equal to half mv square. There is another form of energy, that is potential energy. So first we define it. It is defined as the energy possessed by the body by the virtue of its position. There are two types of potential energy. One is called gravitational potential energy and the another is called elastic potential energy. Now we discuss the first one, that is gravitational potential energy. We can write it as potential energy is equal to mgh. We can prove this formula. Suppose a block of mass m is kept on a surface, the weight acting on a body is in the downward direction, that is mg, and now the block is lifted up with a constant velocity up to the height h. Then the work done is said to be F into d. W is equal to force applied is mg and the displacement is h. W is equal to mgh. Whatsoever of work is done, that is called energy stored in a body due to the position above the surface of earth, that is the E is equal to mgh. In this topic we will study about the elastic potential energy. Suppose a block is kept on a surface which is connected to a spring as shown in figure. Now we applied a force on the block and the displacement produces x. It means the spring will also stretch through a distance x. The displacement produced in a spring is directly proportional to force applied, or we can say F is equal to kx, where k is called the force constant, or we can say the spring constant. Force constant or the spring constant. If we plot a graph between f and x, then we get a straight line and the slope of this graph will give the spring constant or the force constant. To find the energy, we will calculate work done. dW is equal to F dx. Now place the value of force, that is kx, into dx. Integrate both the sides from the position x1 to x2. This is W, k, x square upon 2 from x1 to x2, or we can write W is equal to k, x2 square minus x1 square upon 2. Whatsoever is the work is done, that will be stored in the form of the potential energy, x2 square minus x1 square. In the last topics, we have studied the work done and the energy. Now we can summarize all the formulas for the work done. It is given as W is equal to F vector dot D vector. The another formula to calculate the work done is, that is Fd cos theta. The third one is work done is equal to, we can write it as change in kinetic energy. Fourth one, work done is given as change in potential energy. The fifth one, the potential energy means, that is mg h2 minus mg h1, or we can write it as half k x2 square minus x1 square for the spring. The fifth one is work done is equal to integration of F dx, where F is the variable force. It is the variable force. So by all these formulas, we can calculate the work done.
There are two types of energy, kinetic energy and potential energy. The unit and dimension for energy is joule. The energy possessed by the body by virtue of its motion is termed as kinetic energy. Ke is equal to half mv square. The energy possessed by the body by the virtue of its position is termed potential energy. There are two types of potential energy, gravitational potential energy, elastic potential energy. Gravitational potential energy is the energy an object possesses because of its position in a gravitational field. Pe is equal to mgh. Elastic potential energy is the energy stored as a result of deformation of an elastic object such as the stretching of a spring. It is equal to the work done to stretch the spring, which depends upon the spring constant k as well as the distance stretched. Pe is equal to half k into x2 square minus x1 square. For variable force, work done W is equal to integration f dx.
For more such videos, log on to CBSE section of jagranjosh.com.